Right. So our next topic is types of nuclear reactions. The book I am following for this is V.K. Mittal, Nuclear Physics Mittal. Okay. So in nuclear reactions, classification can be done in two ways. One based on type of reaction. Two based on type of projectile. So based on type of reaction. So మనకి రేడియేటివ్ రియాక్షన్ నాన్ రేడియేటివ్ రియాక్షన్ ఫోటాన్ ఎమిట్ అవుతుందా సో బేస్డ్ ఆన్ ద అవుట్కమ్ ఫైనల్ అవుట్కమ్ ఏం జరుగుతుంది అనే దాన్ని బట్టి టైప్ ఆఫ్ రియాక్షన్ని బట్టి ఒక క్లాసిఫికేషన్ ఉంది అనేది బేస్డ్ ఆన్ టైప్ ఆఫ్ ప్రొజెక్టైల్ వాట్ కైండ్ ఆఫ్ ప్రొజెక్టైల్ వేర్ యూజింగ్ ప్రోటాన్ తీసుకుంటున్నామా న్యూట్రాన్ తీసుకుంటున్నామా అనే దాన్ని బట్టి one kind of classification ఉంది. So the first one is based on type of reaction. So I call this as 1 and 2. So based on type of reaction, the first type is elastic scattering. So here projectile and target will not, they will keep their identity. అవి రెండు అలాగే ఉంటాయి, ఓన్లీ కైనెటిక్ ఎనర్జీ ట్రాన్స్ఫర్ మాత్రం అవుతుంది. ఓకే, సో వన్ ఈజ్ ఎలాస్టిక్ స్కాటరింగ్. సో బోత్ ద ప్రొజెక్టైల్ అండ్ టార్గెట్ న్యూక్లియస్ కీప్ దేర్ ఐడెంటిటీ, ఓన్లీ ఎనర్జీ ట్రాన్స్ఫర్, కైనెటిక్ ఎనర్జీ ట్రాన్స్ఫర్ మే టేక్ ప్లేస్. ఓకే, సో ఎగ్జాంపుల్ ఇస్ 1 and 0 U92 208 gives you back again U92 208 plus 1 and 0. Okay, so that is elastic scattering. Another one is inelastic scattering. So inelastic scattering లో ఏం జరుగుతుందంటే, in addition to momentum transfer there will be some loss of energy in terms of thermal energy కావచ్చు, ఏదైనా కావచ్చు. ఎంటైర్ కైనెటిక్ ఎనర్జీ ఎక్స్చేంజ్ అయితే జరగదు. some of the energy will be converted to other forms. సో ఇక్కడ అది ఎగ్జైటేషన్ ఎనర్జీగా కన్వర్ట్ అవుతుంది. సో we may at once get a photon. సో ఎగ్జాంపుల్ ఏంటి, H11 plus Al 1327 gives you, so still it is elastic scattering, kind of scattering interaction only. So atoms are keeping their identity, but there is a small transfer of energy. So Al 1327 remains as it is, but in excited state, plus H11. So you will get Al 1327 plus H11 plus a gamma ray. So this is excited state of aluminum. Star indicates excited state. So in elastic scattering you have only momentum exchange. Only kinetic energy or momentum will get exchanged. Whereas in inelastic scattering, in addition to momentum exchange, there is an additional activity. So still the particles keep their identity, but somehow the kinetic energy is converted into a photon or a gamma ray. Okay, so that's about inelastic scattering. Third one is radiative capture. So what does it mean? the projectile is captured, releasing a radiation. So the same reaction H11 plus Al1327 gives you silicon 1428 star, which in turn gives you silicon 1428 plus a gamma ray. So radiative capture ante entante projectile is captured, releasing a radiation. So next one is compound nuclear reaction. So compound nuclear reaction ante enti? So there is an intermediate nucleus which is called compound nucleus in the process. So there is a small time gap after the formation of compound nucleus before it disintegrates into smaller nuclei. Okay. So example, He2 4 plus Al1327 gives you phosphorus 1531, which gives you phosphorus 1530 plus 1 and 0. So there comes a compound nucleus in between with a longer lifetime compared to rest of the reaction rates. అంటే మధ్యలో ఒక పాజ్ వస్తుంది ఆ రియాక్షన్ జరిగేటప్పుడు. సో దట్స్ కాల్డ్ కాంపౌండ్ న్యూక్లియర్ రియాక్షన్. సో ఆల్మోస్ట్ ఆల్ we are dealing with aluminum. So next one is photo disintegration. Photo disintegration. So ఇక్కడ ఏం జరుగుతుంది, photon is getting absorbed and the nucleus disintegrates. So H12, we are taking neutron interacting with the gamma, we get H11 plus 1 and 0 and 0. So the nucleus absorbs a gamma ray or photon and disintegrates into lower order nucleus. Next one is direct reaction. సో ఇందులో రెండు పాసిబిలిటీస్ ఉన్నాయి. సో వీఆర్ టాకింగ్ అబౌట్ ప్రొజెక్టైల్. సో డిఫరెంట్ టైప్ ఆఫ్ రియాక్షన్. ఓకే, సో వాట్ హ్యాపన్స్ టు ప్రొజెక్టైల్ అనే దాన్ని బట్టి there are of two types, pickup reaction and stripping reaction. So here in the first case, pickup reaction, projectile will capture one nucleon from the nucleus. Stripping reaction, the projectile will lose a nucleon to the nucleus. So we are dealing with projectile. What happens to projectile and the output అనేది చూస్తున్నాం ఇక్కడ. So it is let's say CO2759 plus H12. Pickup reaction means what? Some of the nucleons will be captured by the projectile. So H12 becomes He24. Whatever remaining is the remaining. So Fe2657. So cobalt converts into iron. Stripping reaction. Yeah. So Au79 197 plus H12. So here the projectile loses a nucleon. What do you get? Hg80 198 plus N01. This is the famous alchemy equation. Opposite to that, when people try to remove one nucleon to get gold from mercury. Here it is the opposite reaction. So this is called direct reaction. I mean, what was happening in all the previous cases? Elastic scattering, both projectile and target keeps their identity. Inelastic scattering, both projectile and target keeps their identity, but some of the energy is converted to gamma. Radiative capture, so the projectile is captured, releasing radiation. Compound nucleus, so there is a time lag in between. And direct reaction, so here some reaction is taking place instantaneously and nucleon exchange is taking place. Here also some nucleon exchange is taking place, but it is a special case where a compound nucleus is formed in between. So ikkada kuda you can have that. I mean, ikkada kuda manaki some kind of stripping reaction or edo okati jarugutundi, pickup reaction, but there is a compound nucleus in between. Right? So without that compound nucleus, these are the direct reactions. Okay. So next one. Heavy ion reactions. So here both projectile and target are heavy atoms, I mean comparable of size. So result is also some kind of comparable size of atoms or nucleus will be generated. So example Al1327 plus N714. So they got shifted. Nitrogen becomes oxygen. So OH16 plus Mg1225. So em chesaru aluminum nitrogen తీసుకున్నారు, you got oxygen magnesium. So both projectile and target are comparable of size and result is also comparable size. So both are heavy. Next one is radiative decay. So this is the starting point for nuclear physics experiments like alpha decay, beta decay and gamma decay. So alpha decay U92-238 gives you thorium. I mean, you have to get an alpha particle, He24. Remaining is what? 90 234. U90 to 238 becomes after alpha decay becomes thorium. Beta decay is of two types, beta plus and beta minus. Beta plus means what? Beta plus proton is converting into a neutron. So on left side and right side you have positive charges. So proton is converting into a neutron. So what happens? Atomic number reduces. So Na 1122 becomes Ne 1022 plus beta plus neutron. So proton is converting into a neutron, so atomic number reduces. Then beta minus atomic number increases. So C 614 gives you N 714 plus beta minus, N 714 plus beta minus plus anti-neutron. And then gamma decay, any higher order interaction, like wherever you come across this, like silicon 1428 is giving rise to silicon 1428 plus gamma. Barium, I mean this is what we'll be using for scanning, radiative scanning. Barium liquid తాగేసి వచ్చినటువంటి గామా రేడియేషన్ ని మనం స్కాన్ చేస్తాం. So what is that? Barium 56137 star gives you barium 56137 plus gamma. They are radioactive decay reactions. Next one, fission reaction, fusion reaction. Fission is well known, U90 to 235 plus neutron gives you barium and krypton. Ba 56 141. What is this? Ba 137. So here it is 56 141 plus 36 92 krypton plus Kr 36 92 plus 3 neutrons again, 3 and 0 ones. Fission reaction. Barium 56 141, krypton 36 92, 3 neutrons. And fusion reaction, so H11 plus H11 gives you H12 plus positron plus neutron. So ఏంటంటే one proton is converting into a neutron. So on both sides you will have positive charges. And elementary particle reactions. So the last one, if the energies of interactions are greater than 300 MeV, mega electron volts, it will generate elementary particles. So they are the 8, 9, 10 and 11. This is 9th one is fission, 10th one is fusion. These are various types of reactions. Next, based on projectile. So ఇంతవరకు క్లియర్ చేయొచ్చా? So now next type of classification is based on type of projectile. So projectile బట్టి మనం న్యూక్లియర్ రియాక్షన్స్ ఎట్లాగా అనేది చూడాలి. So if the projectile has 1 AMU, 1 atomic unit of mass, atomic mass units. So ఏమేమి వస్తాయండి? Your proton and neutron will come into this category. Okay. So we'll see different possibilities. Like we'll start with proton. Proton releasing a gamma. Proton releasing a alpha particle. Proton releasing a neutron. Right. So proton releasing a gamma, proton releasing an alpha particle, and proton releasing a neutron. These are the three possibilities. Same rule applies even for neutron. Neutron releasing a gamma, neutron releasing an alpha particle, neutron releasing a proton. So these are the types of reactions we need to see. So we are starting with H11, the same reaction that we have seen in the earlier case. Al1327 gives you silicon 1428 plus gamma. The same equation we have seen in the previous case. And proton alpha, so N714 plus H11 gives you should get He24. What is the remaining thing? C611. So you know the projectile and outcome also. Projectile and ejectile details are given, so you can write those equations easily. So proton giving neutron. So Na1123 plus H11 Mg1223 N01. This is not beta emission. Beta plus beta minus case line of the proton is converting into neutron, but still it is a part of nucleus. Here the neutron is ejecting out of the reaction. Okay. So and neutron gamma, neutron alpha, neutron proton. Neutron gamma N1123 plus N01 gives you N1124 plus gamma. Neutron alpha Al1327 plus N01 should get He24. The remaining is 11 N sodium 1124. Next neutron and proton. So Al1327 plus N01, you should get a proton. The remaining is Mg1227. And neutron to neutron reaction. N gives you double neutrons. So Al 1327 plus N01, Al 1326 plus N01 plus N01. So next one is reactions by 2 AMU particles. 2 AMU projectiles. So here we are fixing the target, and depending on the nature of the reaction we can decide what to get. So 2 AMU means we are taking deuteron. H12 is the projectile. And target is fixed, Al 1327. So what are the reactions? Deuteron gives you proton, deuteron gives you neutron, deuteron gives you tritium. They are the possible reactions. Target is the same. So Al 1327 plus H12, Al 1328 plus H11, Al 1327 plus H12, neutron means N01, so it is silicon 1428. Tritium is H13, so Al 1327 plus H12 gives you H13, so 13 remains same, Al 1326. Deuteron, tritium. And reactions by 3 AMU particles. So here tritium, H13 is the projectile. So we are taking cobalt 2754 as a target, and the possible reactions are tritium giving you deuteron, tritium giving you neutron, tritium giving you helium 23, tritium giving you alpha particle He24, and these are tritium related reactions. And another possible projectile with 3 AMU is He23. He23. So the target is the same, CO2754, and possible reactions are He23 proton, He23 neutron, He23 tritium, He23 alpha, He23 2 protons. Sorry, correct that. Possible. He23 2 protons. So depending on the type of reaction, you can decide what is the outcome. And 4 AMU particles. 4 AMU means alpha particles. So alpha particle, and we are taking Al 1327 target fixed, and possible reactions are alpha proton, alpha neutron, alpha 2 neutrons. 4 AMU particles. So now other one is heavy projectiles. So earlier we have seen already. What was that? Heavy ion reactions. Aluminum plus nitrogen gives you oxygen plus magnesium. So heavy projectile, and reactions by gamma is already seen. So here it is. What is that? Al1327 plus Cn714 gives you O816 plus Mg1225. Another projectile, gamma projectile. So for gamma projectile, H12 plus gamma gives you H11 plus N01. So these are the types of reactions based on projectile.